Hi again, everybody. This is now moving on to section 5.2, probability problems and the addition rule. This problem number 4 on the handout is an example where you are given a contingency table. A contingency table is also known as a two-factor table. It just gives you two different factors and it's broken up in two different ways. In this case, we have political party right here. Then we have whether a person voted or did not vote over here. And so the first thing that you want to do with any contingency table is to find the totals for each group. So for example, the Democrats, these 475 and these 275, the total for those is 750. And we may need that 750 at some point. If I continue this across here, the Republicans, 356 plus 144 is 500. And the other, these would be independents or Green Party, but just not Democrats or Republicans, 99 plus 51 is equal to 150. Similarly, we would add across the side, the total number of people who voted would be the 475, the 356, and the 99. If you add those up, you get 930. And the people who did not vote, the 275, the 144, and the 51, if you combine those all together, you get 470 people did not vote. Now right down here, we get the grand total of everyone. There were 930 people who voted, 470 who did not vote, for a grand total of 1,400 people. Just to check, if I added 750 Democrats plus 500 Republicans plus 150 others, I would also get 1,400. Okay, now that's going to help us when we answer any of these questions below. So I'm going to scroll down here a little bit. Part A asked, what is the probability that a person selected at random is a Democrat? Okay, well, just like in section 5.1, the probability that someone is a Democrat, switching to blue because Democrats are considered blue, probability that someone is a Democrat is equal to, well, the number of Democrats was 750 divided by the total, which was 1,400. So 750 divided by 1,400, 1,400. And that is equal to approximately 0.5357, or we could call that 0.536 if you wanted. I'm just going to call it 5357. Or you could say 53.6%. 53.6% were Democrats. Okay. Part B says, what is the probability that a person selected at random is not a Democrat? Okay. Back to red. We're now not Democrats. Maybe that's Republicans or maybe that's independents. But not a Democrat means the opposite or the complement of what we just did. So the easy way to do this is to say it's 1 minus the probability of being a Democrat, which is 1 minus 0.5357, which is equal to 0.4643. So about a 46.4% chance that you're not a Democrat. 46.4%. Now that makes perfect sense, right? Because you either are or you are not, and they have to add up to 100%. So there's 53.6% that are Democrats. There's 46.4% that are not Democrats. Okay, part C asks, what's the probability that a person selected at random, they all start the same way, is a Republican, so that's red, or someone who voted. Now, if you recall, the word or indicates we have to add things together. It's a condition that says you could be this or you could be that. So it's either a Republican or someone who voted. Okay, so we have Republicans are this middle column right here. These are the Republicans. And then it says or someone who voted. So I'm going to change colors to orange for someone who voted. That's this right here. These are all the people who voted. Okay? So the main thing you can see is that there's a lot of people that are in one of those two highlighted red areas or orange areas. But importantly, there's 356 people that are in both. Okay, so the general addition rule says it's the probability of being Republican or voted is the probability that you are Republican plus the probability that you voted minus the probability that you are Republican and voted. Okay, so that means we have to subtract the double count, which is a 356. So altogether, for the Republicans, we had 500 divided by 1,400. The people who voted, altogether, we had 930. And then we subtract the people who overlapped, 1,400 people total. The number that overlapped was 356, which is 1,074 out of 1,400, which is equal to 0.7671. So almost 77% of people were either Republicans or they voted. Okay, part D asks, what is the probability that a person selected at random is a Democrat and someone who voted? So the key word there is and, because if it's and, that means it must be both. So a Democrat and they voted. So we have to look back at the table and find out how many Democrats were there who actually voted. That's not all the Democrats and that's not all the people who voted. That's the ones that were Democrats and they voted. So the probability that they were a Democrat and voted, well, that's, let's see, the voted is the first row. The ones who are Democrats are right here. These 475 people. Those are the only people who were both Democrats and voted. So it's 475 divided by 1,400, which is equal to 0.3393 rounded off. 3393. Okay, so hopefully that helps you to distinguish this. The main thing to watch out for on an exam or in any other question is, are they talking about an or statement or are they talking about an and statement? If it's or, you include more, or is more. And if it's and, then it's restricted, so it's only the people that, or the subjects who actually meet the criteria for both things, whether they are Republicans and Democrats or Democrats and they voted or whatever. Okay, thank you.